Hi, thank you for joining. We will learn how to build a more integrated and scalable omics data landscape as we embrace the use of multi-omics data across research and clinical trials. After the talk, hopefully you'll better understand how your organizations will benefit from integrated omics data, why some initiatives fail and others succeed, and how our solution and collaborative process help organizations move from fragmented systems to a fair data landscape. Before we jump in, let me introduce myself and Genestack. My name is Kevin, and I'm leading the data science consulting team at Genestack. I started my bioinformatics journey in Oxford, studying HIV evolution, and then in Cambridge, looking into cancer systems biology. A common theme throughout my career is the importance of data. Successful projects tend to have solid data sets behind them. So I'm very excited that we have gone a long way with multi-omics data. Omics data management is at the heart of what we do at Genestack. We are based in Cambridge, UK. We work with both small and some of the largest organizations, including Roche, AstraZeneca, Unilever, and Corteva. Our flagship product is Omics Data Manager. It's a culmination of our collaboration with industry leaders. It's the best in class for data integration, metadata management, and search. Omics data has now become a key success ingredient for target identification in research to patient selection in clinical trials. However, we still spend far too much time harmonizing and integrating data rather than applying them. This is because of data silos, incompatible data and metadata, and scalability issues. So organizations are now striving for a more scalable and fair data landscape, which is understandable because the benefit is transformative. It leads to data democratization, which increases researcher efficiency, amounting to at least $4 million per year per 100 researchers. It leads to higher data utilization, which causes fewer experiments redundantly done, amounting to at least $2 million per year per 100 experiments. And most importantly, it leads to better target dosing strategy and selection biomarkers, which lowers trial cost and improves the likelihood of success, easily amounting to at least $300 million per drug. This is an example of what you can achieve with a more integrated and scalable data landscape. You'll be able to build a powerful application like a single-cell atlas in just one day by one data scientist, instead of having to wait for a year and investing $1 million. This is only possible if you have solid data integration capability. So, data integration is hugely important for any organization, but it's also very hard to get it right. So now we are going to share the common hurdles to overcome. Here are the 6 common pitfalls. The first 3 are cultural. These are short-term focus on analysis, lack of urgency, and the perception that the problem is easy enough to solve on your own in-house. It's important to have the right culture because integration is a team effort. The next three pitfalls are more technical. These are over-reliance on data lake, fixating too much on data visualization, and overdependence on general purpose technology. So now we'll see how to address them. The first pitfall is that organizations tend to have a short-term focus on data analysis rather than long-term data integration. But you have to realize that data is an asset. It grows in value through integration. Because some classes of insights, like target identification and patient selection, are only possible when you have a broad and well-annotated dataset. The second pitfall is the lack of urgency. Unfortunately, as with many things in life, the longer you wait, the harder it gets. It's well known that data preparation is the most time-consuming and least enjoyable part of data science. So you want to have data harmonization and integration as close to data acquisition as possible. The third pitfall is the do-it-yourself mentality. We have seen big organizations going down this route but eventually gave up. It's unsustainable, expensive, and even worse, you might end up with another data silo, which is the frustration shared by one of our pharma clients recently. The fourth pitfall is over-reliance on data lake. Data lake won't help data integration because it tends to lack data standardization, data lineage, and metadata control. What you need is to organize and structure data into single point of truths. Have an integration layer on top to model relationships between data modalities, and have metadata management to ensure minimum information is captured using ontologies and controlled vocabularies. Another pitfall is focusing too much on data visualization. What you'll find is that data visualization apps tend to be limited in data and functionality. You end up having to track data across multiple apps, which leads to fragmentation. So a more sustainable approach is to have a single point of truth for your multi-omics data and serve it to different applications via APIs. So you want to invest into a centralized and reusable data and search capability. And the last pitfall here is overdependence on one technology. General purpose big data technology, like Spark, may not be the best choice for all data types and use cases. For example, we managed to get superior performance for genomics filtering and association analysis on a single machine compared to spinning up a big Spark cluster. So, in summary, these are the lessons learned. It's important to understand the value, urgency, and difficulty of omics data integration. You want to ensure good data standardization and semantics. You want to invest in common data and API framework. And to ensure scalability, you want to match different technologies to data types and use cases. And now I'm going to share how our product and collaborative process successfully help organizations in their data integration initiatives. These are the 4 steps in our process. First, we would start with a discovery phase to identify gaps and integration points. Then we would deploy relevant modules of Omics Data Manager, our product, to fill in the relevant gaps, followed by integration with existing capabilities. And to keep up with the growth in omics data, we would pursue knowledge and cost sharing to achieve strategic and accelerated development. Let's explore these steps in more detail for a typical organization. During the discovery phase, we would typically find a fragmented landscape where you have unstandardized and unorganized data in file system and data lake on one side, and on the other end, you have data scattered across multiple visualization applications. What's missing is a standardized data and access framework, something in the middle. So we'll deploy our relevant product modules to bridge this middle gap. It's a central organizing layer for standardizing and connecting data and metadata. And it provides a standardized data and access framework for different apps. We would build this on top of your existing capabilities. For example, we would use terminologies and ontologies to enhance the metadata management capability. We would integrate with existing omics and clinical data stores and connect with the wider data catalog. The omics field is growing rapidly. As we have seen during the presentation, building a data landscape is difficult and challenging. So we would encourage building an industry standard solution together through knowledge and cost sharing, where we can strategically avoid common pitfalls and accelerate development. 2 particular areas that we are focusing on right now are single cell and clinical data integration, especially for ongoing in-flight trials. This is an exciting time and an opportune moment for you to join the likes of Roche and AstraZeneca. That's the end of my presentation. Thank you for listening. You are welcome to visit our booth. You can find it under the exhibitors tab on the conference virtual platform. We are holding daily product demos, and our experts are available to help with your data challenges. Once again, thank you for listening. Feel free to grab me in the booth or ask questions during the live Q&A session after this talk. Thank you.